Welcome all for today's lecture. Today we are going to discuss on embedded system digital camera case study. In today's lecture we will study about embedded systems using a real world case study like the digital camera. Instead of learning embedded system only through theory, this case study will help you to understand how embedded system and software hardware work together in a real product that we use every day. By the end of this lecture, you will have a clear understanding of why a digital camera is called an embedded system, its hardware and software components, how image captures, processing, and storage happen, how modern cameras become smart using embedded intelligence. Let us begin with the concept. Let me start with introduction. What is an embedded system? An embedded system is a dedicated system that combines hardware and software to perform specific tasks efficiently. Unlike a general purpose computer, which can run many applications, an embedded system is designed for one fixed function. Now, think about a digital camera. A camera is not used for browsing the internet or writing documents. Its only purpose is to capture image or videos, process them, store or display them. This makes a digital camera a perfect example of an embedded system. Inside the camera, there is a specialized hardware and optimized software working continuously in real time to give you a clear photo with just one click. Digital cameras are considered as a sophisticated image system as they integrate image capturing, storage, and control operations which using specialized processors and controllers. Next, we are going to discuss on digital camera embedded systems. A digital camera is considered as a sophisticated embedded system. Why sophisticated? Because it performs multiple tasks such as image capture, image processing, image storage, image display, user interaction. All these operations are controlled by embedded processors and controllers. The key insight here is embedded system make cameras an intelligent device. Like it adds the features like face detection, autofocus, auto exposure, real-time image analysis. All are possible only because of embedded software algorithms running on dedicated hardwares. So these are things which is given as a image. We have a camera module, capture logics, RAM, JPEG, SDRAM control, SDRAM memory, SD card, RAM buffers, VGA, filters and VGA display. These are everything is combined together to make a digital camera to work as a specific task. Next, we are going to discuss on evaluation of cameras. Let us understand how cameras are evolved. Earlier analog cameras use photographic films, no electronics, manual processing is required. Everything we need to take as a film and we have to develop it. It took a huge amount of time to see what we capture, whether captured images comes correct or not. So on the other hand, if you come into the model digital cameras, which uses CMOS or CCD image sensors, which converts light into a digital data, which uses embedded processors to process images. One important historical example, the first commercially available digital cameras, Dicam model, which was introduced in the year 1990. From that point onwards, embedded system revolutionized photography by making cameras faster, smaller, smarter, and more affordable. Next, we are going to discuss the basic functions of digital camera. A digital camera performs three essential functions. First one is the image capturing. Generally, the image capturing happens by converting lights into digital signals using sensors. Let us discuss how it happens. Light enters through the lens, falls on the CMOS or CCD sensors. Sensor converts light into electrical signals. These signals are converted into digital data. This is the input stage of an embedded system. Next one is image processing. The image processing which compresses, enhances and prepares image for storage. So the raw image data contains noise. Embedded processors performs noise reduction, color correction and image compression. This is where the intelligence of the embedded system plays a major role. Next one is the storage and display. The processed images are stored in internal flash memory cards. Images are displayed on LCD or OLED screens. All these operations happen within milliseconds, give you an instant results. So the embedded system makes a digital camera to work much smarter than how we expect. Next one is embedded hardware components. Let us examine the hardware inside the digital camera. The main hardware are image sensors, CCD or CMOS, which acts like a human eye, which takes the picture and converts the lights into digital signals. The next one is microcontroller or DSP, which acts as the brain of the digital camera, controls all the camera operations. DSP is used for high-speed image processing functions. Next one is memory. Here we can use two types of memory, either flash memory or SD card memory. The flash memory for image storage and RAM or SD cards for temporary data during processing, and we can store the image with the help of the SD cards, and we can take it into outside and we can store it in any devices what we like. Next one is the display or UI interfaces. The display which is done with the help of buttons, touch screens, everything, and the LCD display for preview and playback. Next one is the storage control, which handles reading and writing images into a memory cards. The next one is communication interfaces. The communication interfaces which comprises of USB or serial interfaces used for transferring photos to a computers. Each of these components is tightly integrated into an embedded architecture, and it will display a quality functioning of a digital camera. The next we are going to discuss on embedded software tasks. As we discussed earlier, the embedded system which comprises of hardware as well as the software roles. Throughout we have discussed the hardware roles. Next we are going to discuss on the roles of softwares in digital camera. The real power comes from the embedded systems. Hardware alone is not enough. The software in a digital camera performs the following tasks, like it controls image sensor parameters like exposure and focus, and executes image processing algorithms for noise reduction, color correction, everything, and manages the user interface environment, handles the memory and file systems, and enables smart features. Examples of smart features that includes face detection, object tracking, scene recognition. All these are implemented using efficient real-time embedded software. Next, we are going to discuss on smart cameras. So the modern cameras are becoming smart cameras. They include advanced features such as real-time person detection, motion analysis, and scene understanding. These cameras are widely used in robotics, security systems, industrial inspections, and surveillance. Here, the embedded systems combine sensors, processors, and AI-based algorithms to make intelligent decisions without human interventions. Next, we are going to discuss on the benefits of an embedded system. Why embedded systems in cameras? Why we need to use especially the embedded systems? The key benefits are it consumes low power because it is a battery operated devices, so it consumes very less power, low cost due to mass production, real-time performance, optimized hardware for image tasks, efficient and reliable operation. Embedded design ensures maximum performance with minimum resources. Next, we come on to the conclusion of the digital camera. Digital cameras are excellent real-world examples of embedded systems. They integrate sensors, processors, memory, and software to deliver advanced imaging features. The evolution of digital cameras clearly shows how an embedded system design drives modern technology. So this technology has evolved significantly due to embedded systems. Thank you. Thank you for your attention. We will come back to the next lecture. Thank you.